Hello, everybody. Thank you all for joining this webinar today. Today we will be talking about our IP SIP horn loudspeaker and amplifier module, and we will specifically be addressing the firmware release 2.0. So today the webinar is being recorded, so if you afterwards want to review the webinar, that is no problem to go through once more through the details, or in case you missed it. Please, in case if you have questions, post them in the chat, save them until the end of the presentation, and then afterwards we will go through them and try to answer them as good as possible. If you look in the WebEx interface at the right bottom corner, you see the chat window where you can post your questions. So today I am here together with my colleague, Dominique Treipel. He's application engineer for business unit communications. And myself, Maaf de Winks, a regional marketing manager for the EMEA region. So as mentioned, today we want to inform you about our IP horn loudspeakers, understand the use cases and the benefits of the product, and enable you to promote this product. We, for now, for sure, will be going in and emphasize a little bit more on the firmware 2.0 features, but we will also do a short recap of the product in general. So today we will be going through the various topics. So let's start with the first one, focus applications for the IP horn. Well, where is this horn typically used? Well, one of the applications where it could be used perfectly is, for instance, perimeter protection. So here you see the example of an IP horn, which is being installed on the perimeter fence. And if an intruder is approaching the fence, then video analytics will trigger an event in the camera. And this event in the camera can be used to trigger a pre-recorded message on the loudspeaker. So one of the advantages that we have with our IP horn is that we can have a direct integration between the camera and the loudspeaker through the so-called alarm tasked script language, which is a scripting that runs on the camera and allows you to trigger one or multiple horns at the same time, triggering a pre-recorded message. Another use case is that somebody is sitting in a security control room and he sees an event which is brought forward in his software at the security control room, and he wants to make an intervention without specifically sending a security guard. So what he can do from the security control room, he can talk through the speaker, and the speaker also has a possibility to have a talkback functionality. So the person who is standing in front of the speaker can also talk back to the security control room. So you get a bit of a bidirectional communication. So this is one of the features which not all of the IP horns on the market are featuring. So this is specifically something which we want to highlight because we have an integrated microphone on the IP horn loudspeaker, which some of our competitors don't have. Yeah. Then there is also the remote speaker test. So in case you have speakers installed somewhere in the field, may it be in an outgoing area in a smart city concept, or may it be along the perimeter fence where you have long fence lines, you are usually dealing with long distances. So you don't want to go to every speaker to listen if it is producing sound. You want to test this remotely. So what we can do from the web interface of the loudspeaker is that we do a remote test. Then the loudspeaker is actually producing sound, and the integrated microphone is capturing this sound and giving a feedback that the loudspeaker is actually okay. It's testing the sound, it's testing the Ethernet connection, and it is also testing the power over Ethernet capability. Then another feature that we have is noise level triggering. So in case there is a sudden change in noise level, or it exceeds a specific threshold, then we can make the loudspeaker trigger a pre-recorded message. So now imagine you have this installed somewhere at a specific location, maybe at a remote platform of a train station or something like this, and then suddenly When a lot of noise is being produced, where it is not expected, we can actually make this loudspeaker automatically trigger a pre-recorded message. Then a nice feature we have, which we should definitely highlight when we talk to our customer, is the automated volume control on the speaker. So if the ambient noise level is low, we can tune down the volume, and when the ambient noise level is high, we can tune up the volume. So where is this relevant? Let's imagine we now have a construction site somewhere. During the night, you might not want to make your announcements too loud, because the ambient or the neighbors next to that construction site might start complaining about these announcements. So if the environment is quiet, we can tune it down to the appropriate level. But during the daytime, maybe when it's quite busy and there is traffic around, we just want to generate more volume on the loudspeakers so that it is also properly heard. So depending on the situation, sometimes it's better to have a lower volume, and sometimes it's better to have a higher volume. It depends a bit on what the environment is at that specific moment in time. So our loudspeaker can adjust itself. This is something which most competitor loudspeakers cannot do. So this is also a feature which we want to put, which we definitely want to put forward. What we can also do is make direct integration between the camera and the loudspeaker using the audio in and the line out connections between the camera and the loudspeaker. So in this case, actually, the camera is connected through the video management software. Some cameras also give the ability that you can actually talk through the camera. But if we connect on the loudspeaker, we are actually reinforcing that, that audio using the loudspeaker. And if somebody talks back to the speaker or the camera, we can also use the microphone of the loudspeaker and feed that back into the camera and bring that audio signal to the security control room operator who is sitting in the control room somewhere remote. Yeah, so here a very robust direct connection using audio in and audio out between both of the devices. Yeah. Further integration options are that we have REST API and HTTP API on the product. So this allows you to control the product from third-party applications, giving you the possibility to do virtual triggers from a user interface, for instance, that you start playing recorded messages, but also things like the volume control for mains, line outs, for the microphone. These are options that you can address through the APIs. From the security control room, there is also a SIP interface possibility. So your loudspeaker will basically get a phone number. And if the security control room operator sees something happening at the scene, he can pick up the phone, he can dial the loudspeaker, and he can talk through the loudspeaker into the scene. If somebody talks back to the loudspeaker, he will also hear that through the phone. So he more or less can have a conversation with the person who is creating this unwanted situation, and by that means make an intervention. So our loudspeaker is best combined, obviously, with the video portfolio that we have. So in video, we have a few specific use cases where we have a specific algorithm offerings which are tuned to the optimal behavior in such use cases. So one would be the Intelligent Video Analytics Pro Building Pack, one would be the Perimeter Pack, and one would be the Traffic Pack. So those are use cases where video is also offering best-in-class analytics, where our IP horn loudspeaker can be used in combination with our own portfolio. So definitely when we are promoting this loudspeaker, if people are already using the Bosch camera, it's obvious that having both of them from the same brand is a benefit that we want to push. more or less one-stop shop concept, where we have a high performance IP loudspeaker with good audio quality and nice features sitting next to intelligent cameras with best-in-class video analytics. And if you look at these use cases, things around the building, protecting parking lot areas, protecting gates which are giving access to industrial sites or building parks, perimeter fence solutions like border control, or maybe also industrial sites or something like this, or traffic scenarios. These are all use cases where also the IP horn finds application. So now we come to the a new part of the IP horn, because we already have the IP horn for a year now, but now we have also released a new firmware 2.0. It's important to know that there is not any change on the hardware. So this is exactly the same as we have been selling for the last year. It's just a firmware upgrade. If you want to bring the product up to the new firmware, then you just need to upgrade the product, and then it will be equipped with the new features. That's the way it goes. There is no change on hardware necessary. Yeah. So what is new with this the 2.0 version? So the biggest change is basically that we are now supporting the ONVIF protocol. ONVIF protocol for audio, which allows us to be compatible to video management software, which is supporting ONVIF. We were limited to the SIP interface before, but now with ONVIF, we also have a seamless integration with video management softwares which are supporting this. ONVIF is a well-known standard from the video side, but it also has audio capabilities, and these audio capabilities are now addressed also with our IP horn. So we have tested our IP horn with two specific softwares from third party. So one is Genetec Security Center, and the other one is a Milestone X Protect. With Security Center, we already had the interface through SIP, and we are extending this now with ONVIF. With Milestone X Protect, we are now having the integration via ONVIF. This was a bit of a limitation, which we did not have before. So we also foresee now that new business opportunities will open, because Milestone is really one of the leading platforms for video management software in the EMEA territory, and their X Protect software is a well-known product. Yeah, we have also tested it with BVMS. So there, the ONVIF implementation is not yet fully ready. It is on their roadmap, but we have at least tested it, and there are workaround scenarios how you get the IP horn also running with BVMS. It allows a little bit of scripting, but in the end also there, nice use case scenarios can be realized. So what features are supported? So it's the live audio, it's the talk back, triggering of pre-recorded message from the video management software, and the camera loudspeaker association is possible for alarm follow-up. So if the floor plan pops up, you get the camera image, but also the associated loudspeaker. So it's easy for the operator to do the follow-up. Yeah. Good. So this is a small recap of how it works. So we have the security control room where the security operator is sitting. Yeah. And then now, without the using of scripting, we are actually now using the ONVIF protocol. And through that, we can start a live audio talk and listen session remote into the scene. This is basically what we are now supporting. Obviously, to make the use case really nice and seamless from the end user perspective, it's important that we get the camera and the IP speaker association, so that the operator does not need to look for the camera that is associated with the location of the camera, and everything comes together during the scenario of the alarm follow-up. Yeah, so here you see an example where you see the pop-up. An loitering event, for instance, is now being detected by the camera video analytics. This gives a trigger to the security management software. Security management software is popping up the correlated video image for the operator to have a look at the scenery, see what is going on. And automatically, because this programming is done in the proper way, you also see that there is an associated IP horn loudspeaker, which is relevant to the scene. And here from the user interface, the operator can directly access this IP horn loudspeaker and talk into the scene, and also listen to the talkback, both not through the SIP protocol in this case, but through the ONVIF protocol. We have a bidirectional audio communication. So this is the response from the operator. The advantage is that if this person now already responds to the event, it's not necessary to send a security guard anymore, and also intervention is much quicker. Good. Then we have interfacing for SIP. So we already had it with the version 1.0. So we have a peer-to-peer connection where we make a direct call from a telephone to the IP horn. And of course, we had the PBX interfacing for VoIP, where we are calling through an IP PBX, one of the modules or one of the IP horn loudspeakers. But in addition to this, we have now also made this firmware suitable for cloud-based PBX, which was not possible before. So now with this new version, also, if you have kind of a virtual PBX running in the cloud, it is also possible to use that service and make calls from VoIP telephone through the cloud PBX to any of the IP horn loudspeakers or IP audio module. Yeah. So once more, a summary of the use cases where this could be very relevant and how it usually goes. So if you, for instance, take here building security, usually you have a security control room. If the site is really big, it's probably on the premises, but very often this can also be remote. We will have perimeter surveillance. We will probably have parking lot surveillance or surveillance around the building itself, detecting things like burglary, loitering, or whatever other event, people trying to penetrate the perimeter fence. Alarms are being triggered, popping up in the security control room, and either through SIP or through ONVIF, depending on how the connection is being realized, the operator can give a response to the event through the IP horn, with also the possibility for talkback. Yeah. So here we have some application examples where we could use this also. So here you see, for instance, an outgoing area with some cafes and bars. During the day, probably pretty quiet. During the night, things might happen. So also there, alarms might pop up and you want to speak into the scenery. So also here, definitely the automated volume control will be a good feature to have, because if it is loud during the outgoing times, then you want to have a higher audio volume, because the audio needs to be 10 dB above the ambient noise level. And it's obvious that during the day, you will have a completely different situation than during the night. So it's important that the loudspeaker is adjusting itself to the context of use. So also here, a combination of the video camera and the IP loudspeaker. Here we see some other examples also of a parking lot where this could be relevant, or some bus stations where rioting might take place, or you see situations with aggression. These are all nice situations where the IP loudspeaker could be used. Yeah. Also, industrial sites, you very often have also their loudspeakers installed to make announcements to staff working on the ground. You can also use the loudspeaker not only for security purposes, but also for business purposes, to streamline processes. give guidance maybe to lorry trucks if they are not parking correctly in the docking area or something like this. So it's not only a security context in which we can use these loudspeakers, we can also use them in contexts where we are basically managing processes and not only security applications. Yeah. Then we have here also remote areas. Sometimes when areas are really remote, an IP loudspeaker could be used for PA applications, not only security applications, like here on a very distant remote platform. We maybe do not want to put a full-fledged PA system there with amplifiers and everything. There also an IP loudspeaker could be a good solution. If we want to address the crowd on the platform, then it's just simply mounting the IP horn loudspeaker from which we can make announcements and talk to the crowd. So now I would like to hand over to my colleague Dominic. Dominic, can you run us a bit through the product details?
Yeah, thank you. So I will go now with you through the product details. The Bosch IP horn loudspeakers, they are designed for excellent speech reproduction. The housing is racked and water and dust protected, so it is ideal for outdoor and also severe indoor applications. The IP horn is by standard supplied with a stainless steel mounting bracket. We have two different models, the long throw with a higher output to cover longer distances, and the wide angle version, which is more compact and has a broader coverage. Let's have a look at the key characteristics. There is a single cable operation, meaning power, communication, and control all in one cable. There's DSP with EQ and presets for music and speech integrated. We have an internal message storage and player, and the GPIO and line in, line out audio connections. There's direct camera integration based on the Bosch Alarm Task script language, and making announcement from a SIP or ONVIF based system with talkback via the built-in microphone is also possible. Here you can see the built-in microphone of the IP horn. It can be used for SIP and ONVIF communication and for testing the loudspeaker. Also, noise detected by the microphone can be used to start an action like playing a message. And it can be used for automatic volume control. If the microphone is not needed, it can also be disabled via a hardware switch inside the loudspeaker. Here you can see the back of the loudspeaker with the connectivity details. On the left-hand side is a PoE network port for power, communication, and control. On the right-hand side, we have a block divided into two parts. First, the GPIO terminal with one GPO and one GPI. And second, the audio terminal with one line in and one line out. Below, we have an on-off switch for the microphone. And there is also a physical button for test and reset purposes. So this button will perform different actions depending how long you press it. The IP loudspeakers and the module can work with PoE and PoE+. Depending on that, we have different maximum sound pressure level. The IP speaker has 300 megabytes storage capacity for messages with file formats like WAV or MP3. Several protocols are supported like NTP, TCP, UDP, and so on. And the material is ASA. So ASA is as tough and dependable as the tried and trusted ABS, but ASA is much more UV stable than ABS, so it performs better outdoors. We also have an IP amplifier module. So the Bosch IP amplifier module is designed a flexible solution because you can use it for different applications. It interfaces with an IP, SIP, or ONVIF system on one side and has a low impedance and a line level output on the other side for connection to loudspeakers directly or via a local amplifier. It has almost the same key characteristics as the IP speakers, except for the microphone. Here you can see the connection details of the amplifier module. So PoE network port for communication and control, GPIO terminal with one GPIO and one GPI, then the audio terminal with one line in and one line out, and additional for the amplifier module, we have a passive loudspeaker connection for low impedance speakers. And also the IP amp module has a physical button for test and research purposes. The line out of the amplifier module is parallel to the loudspeaker output, except you set a manual routing. So if you are calling the module via SIP or ONVIF, it can be either routed to the low impedance output or to the line output and then using a local amplifier. So both is possible. You may want to link a Bosch camera directly to the IP speaker or module so that it plays a message when an action occurs. To do this, you need to create a special API profile and a rule at the speaker, at the IP speaker or module. Then you need to create a script in the camera using the alarm task scripting language and configure the areas that trigger the alarm at the camera. This script will then trigger a virtual control input of the IP speaker or module. In a system with many devices, an operator may want to centrally supervise all devices and start actions. A quick and easy way to do this is to share system states over an HTTP API, which communicates between the devices in a system via the hypertext transport protocol. This provides an easy way to collect and process requests. The main function is to set virtual contacts, but you can also read out status information from virtual GPOs, virtual GPIs, or system states like message playing. Before starting the configuration operation of the loudspeaker and the module, it is advised to download the firmware from the Bosch product catalog and update the firmware using the Omnio firmware upload tool. IP address detection can be done using this firmware upload tool or also the Bosch configuration manager, as the ISP speaker and the module support ONVIF discovery. And then you log on with the web browser using the IP address or the host name. So the configuration of the loudspeaker and the module is done via web-based GUI. So you just need to open a browser and enter the IP address or the host name of the device. You can use then the overview page to view 4 functions: users, zip, messages, and rules of the web interface, and to navigate to those functions in the system using the informative graphical tiles. Each tile displays configuration data and real-time status information of the device. And to access all the other functions of the device, use the navigation menu on the left-hand side. Here as example, the IP horn device test. The device test field allows you to perform 3 different types of tests to your device. Loopback, only available for the IP horn, tests the speaker and the microphone. Ethernet tests the speed of the Ethernet connection. Power supply tests the actual power supply consumption. To run any of these tests, you just need to click the button Start Test, and the table then displays the results. Notice you can only run these tests if all device rules are inactive. The results of the device test can then be provided also via the API interface. Which is, for example, this, because there is a complete list of states and servers available via HTTP API. So if you want to test the API, you just need to type in the IP address of the horn +/API/index.html to get an overview of the possibilities of the API and also to test and demonstrate the API. The HTTP API provides states for getting and setting virtual GPIOs, getting system states like PoE state, high memory usage, speaker tests, and so on. And also getting and setting controls like user level, mic level, and line level. So an easy way to test and demonstrate the API. There is an application note for getting started with the IP horn loudspeaker and IP horn amplifier module. It describes how to get the IP horn loudspeaker and the IP horn amplifier module up and running. On the example of the wide angle IP horn loudspeaker, it is described how to update the firmware and configure some basic use cases like direct Bosch camera integration using the alarm task scripting language, then to zip examples, and how to trigger a message via noise. It is also explained how to test and reset the speaker. The application note can be downloaded from the Bosch website via the product catalog. So just go to Bosch Security and navigate to the IP horn loudspeaker. Let's have now a closer look on the different firmware releases. Version 1.0 was the initial version released in April 23, and version 2.0 adds, as Mon described now, the possibility to integrate the IP horn and the amp via ONVIF into video management system. If you want to know always more details about the release, you can check this in the release notes, and because the release notes give an overview of new functionality compared to previous releases, like shown in the next slides. Here you can see the overview of the main features of the initial release version 1.0. As shown before, there are features like SIP, direct Bosch camera integration, store and play messages, etc. And here you can also see if the feature is supported by the horn and the amplifier module, or only by one type of the device. As well, you can find in the release notes an overview of the main functions added with firmware 2.0, like ONVIF back channel and ONVIF streaming. ONVIF stands for Open Network Video Interface Forum and it is a standard for the communication between different IP-based security systems used by video management systems and cameras. The audio stream from the device, in our case the IP horn, to the VMS is called ONVIF streaming. But ONVIF offers also the option to send media back from the VMS to the client. So in our case, the IP horn loudspeaker or the amplifier module. That's the ONVIF back channel. The ONVIF output is a virtual control output in the video systems. It can be used to control the state of a virtual control input of the IP horn or amp via ONVIF. Also, some changes for the SIP applications like configurable timeouts of non-audio packets and configurable SIP port, and thus supporting applications like Genetec Sipilia Cloud were added to the release 2.0. And public NTP servers are supported, and also some web GUI improvements were added. Some details about the firmware upgrade. The firmware is available as MSI installer, which will install the firmware file itself in the correct location of the firmware upload tool. There is one installer for the two horns and one for the amplifier module. Firmware upload tool version 9.10 or above is needed. For more information, you can also check the user manual. Existing IP horns and amplifier modules can be updated to the new firmware 2.0. And depending on the installed firmware, the existing configuration will be either migrated or set back to factory default. And what is new with the firmware 2.0, it is possible to disable the firmware update. Let's talk about SIP. The session initial protocol is a signaling protocol used to manage, so to initiate, maintain, and terminate communication sessions involving voice, video, and also messages. So this application protocol can be used to transmit all types of digital media. So it is a specific technology, that can be used for voice over IP. And on the IP horn, you can create two types of accounts. The peer-to-peer account, applicable for direct SIP phone to IP horn communication, and the registrar account, applicable if the IP horn connects to a SIP server. As you can see on the right-hand side, there are three different applications with SIP servers supported. First, the in-house SIP server with no connection to the internet, meaning the SIP phone, the SIP server, and the IP horn are all in the same local network. Then the SIP trunk, where you have a connection to the voice over IP provider via the local SIP server using SIP trunking, and the IP horn is connected to the local SIP server. And new in the release 2 that the IP horn can communicate directly with the voice over IP provider without a local SIP server. That is possible now because the SIP port can be configured. And last but not least, I would like to show you a few details about the VMS integration. The ONVIF standard does not have a device type specifically for audio only. Therefore, the IP horn is added as camera. However, the icon displayed in the live stream clarifies that it is a speaker. New rules like ONVIF audio and ONVIF output were added to the IP horn and amp. And 33 ONVIF outputs are available. 1 to 32 are virtual outputs to trigger rules. And 33rd is the physical GPO of the IP horn or amp. Application notes are available for Milestone and Genetec integration, and for BVMS it is in progress. On the right-hand side, you can see a table of features supported by different video management systems. You always must check the VMS documentation to see if and how these ONVIF features are implemented. So what does the VMS need to support the IP amp? You need ONVIF backchannel for the audio from the VMS to the IP horn. The audio codec G.711 and AAC can be used for that. You need ONVIF audio streaming for the audio from the IP horn to the VMS. Also here, the audio codec G.711 and AAC can be used. And you need ONVIF output. So again, 1 to 32 are the virtual outputs to start messages, and the 33rd controls the physical GPO of the IP horn or amp. Notice, although ONVIF is a standard, there are differences on the actual support based upon the specific VMS. The EMS version tested together with the IP horn and loudspeaker amp module are Genetec Security Center, Milestone Protect, and Bosch BVMS. So please check the application notes if you want to know more details about these applications.